Welcome to Target Teach Tutors. Organic chemistry is all about carbon-containing compounds, and two of the most fundamental types of hydrocarbons are alkanes and alkenes. These compounds play a vital role in fuels, plastics, and various industrial applications. If you are preparing for your GCSE exams, understanding their structure, properties, and key differences is essential. So let's dive in and explore the important hydrocarbons together. First of all, alkanes. Alkanes are saturated hydrocarbons, meaning they contain only single bond between carbon atoms. They follow the general formula CnH2n plus 2 and are relatively unreactive compared to alkenes. Since they are like double or triple bonds, alkanes undergo combustion and substitution reactions but not addition reactions. Examples of alkanes: 1. Methane, CH4. The simplest alkane, methane, is the primary component of natural gas and is used as a fuel. Second, propane, C3H8, commonly used in cooking and heating. Example in propane gas tanks. The third one, butane, C4H10, found in lighter fuel and aerosol propellants. Here are the key properties of alkanes. Physical properties of alkanes. Non-polar nature. Alkanes are non-polar molecules due to the small difference in electronegativity between carbon and hydrogen. Insoluble in water. Since they are non-polar, alkanes do not dissolve in water but dissolve in non-polar solvents like benzene. Low boiling and melting points. As the molecular size increases, boiling and melting points increase due to stronger van der Waals forces. Less dense than water. Alkanes have lower densities than water, making them float. Finally, odorless and colorless. The smaller alkanes, methane, ethane, propane, are colorless and mostly odorless in their pure form. Chemical properties of alkanes. Basic formula for alkanes is CnH2n plus 2. First chemical property is combustion. Alkanes burn in oxygen to produce carbon dioxide and water, releasing energy. The common equation is CnH2n plus 2 plus O2 produces CO2 plus H2O plus heat. Second one, substitution reactions. Alkanes undergo substitution reactions with halogens. Example, chlorine and bromine. Here are two examples of substitution reactions of alkanes with halogens. Example 1. Methane with chlorine, that means chlorination of methane. When methane CH4 reacts with chlorine Cl2 in the presence of UV light, a hydrogen atom is replaced by a chlorine atom, forming chloromethane CH3Cl and hydrogen chloride HCl. The reaction is shown here. CH4 plus Cl2 produces CH3Cl plus HCl. Further substitution can occur producing dichloromethane CH2Cl2, trichloromethane CHCl3 and tetrachloromethane CCl4. Example 2. Propane with bromine, that means bromination of propane. When propane C3H8 reacts with bromine Br2 under UV light, a bromine atom replaces one hydrogen atom, forming bromopropane C3H7Br and hydrogen bromide HBr. The reaction for this is C3H8 plus Br2 produces C3H7Br plus HBr. This can result in multiple products depending on which hydrogen is replaced: 1 bromopropane or 2 bromopropane. The third one is cracking. Long chain alkanes can be broken down into smaller alkanes and alkenes using heat and catalysts. Here is an example of cracking of an alkane. Cracking of decane, C10H22. When decane is heated in the presence of a catalyst, it breaks down into smaller hydrocarbons, including alkene and an alkane. The reaction for this is C10H22 produces C5H12 plus C3H6 plus C2H4. The products are pentane C5H12 is an alkane, propene C3H6 is an alkene, ethene C2H4 is an alkene. The explanation for this: cracking breaks long-chain alkanes into smaller alkanes and alkenes. The alkanes produced are useful for making plastics and chemical synthesis. The smaller alkanes are used as fuels. Points to be remembered here: the reactions require UV light to initiate the reaction. Substitution occurs step by step, leading to multiple halogenated products. Halogens like chlorine, Cl2, and bromine Br2 react more readily than iodine I2. The second hydrocarbon is alkenes. Alkenes are unsaturated hydrocarbons that contain at least one double bond between carbon atoms. Their general formula is CnH2n. Because of the double bond, alkenes are more reactive than alkanes and undergo addition reactions such as hydrogenation and halogenation. Examples of alkenes: first one, ethene C2H4, also known as ethylene. It is widely used in making plastics, polyethylene. Second one is propene C3H6, used in the production of polypropylene, a common plastic material. Third one is butene C4H8, found in the manufacturing of synthetic rubber and fuels. Physical and chemical properties of alkanes. Physical properties are nonpolar nature. Alkenes are generally nonpolar due to the small difference in electronegativity between carbon and hydrogen. Insoluble in water. Like alkanes, alkenes are insoluble in water but dissolve in nonpolar organic solvents like benzene or ether. Boiling and melting points. Alkenes have lower boiling and melting points compared to the alkenes of similar molecular mass. Their boiling points increase with molecular size. Density. Alkenes are less dense than water, meaning they float. Finally, the smaller alkenes, example ethene or propene, are colorless and odorless gases, while larger ones are liquids or solids. Chemical properties of alkenes. Alkenes are more reactive than alkanes due to the presence of carbon-to-carbon double bond, which undergoes addition reactions. There are three chemical properties. First one is combustion, second one is addition reaction, third one is polymerization reaction. We'll take the first one, combustion. Like alkanes, alkenes burn in oxygen, but they produce sooty flames due to incomplete combustion. It shows the common reaction CnH2n plus O2 produces CO2 plus H2O plus heat. The second chemical property is addition reaction. The double bond allows alkenes to undergo addition reactions including, first example, hydrogenation, addition of H2, converts alkanes into alkanes using metal catalysts like nickel or platinum. C2H4 plus H2 produces C2H6. The second example is halogenation. That means addition of X2. Reacts with halogens like bromine Br2 or chlorine Cl2, turning orange bromine water colorless, which is a test for alkenes. The reaction for this is C2H4 plus Br2 produces C2H4Br2. The third example is hydration, addition of H2O. Reacts with steam in the presence of a phosphoric acid catalyst H3PO4 to form alcohols. The reaction is C2H4 plus H2O produces C2H5OH. The third chemical property of alkene is polymerization. Alkanes can link together to form polymers such as polyethylene from ethene. The common reaction shows here. NC2H4 produces C2H4N. Test to differentiate alkanes from alkenes. The most common test to distinguish alkanes from alkenes is the Bromine Water Test. How to do the Bromine Water Test? The procedure is: add a few drops of bromine water, Br2 in water, orange or brown in color, to separate test tubes containing the alkane and alkene. Shake the test tubes and observe the color change. Observations are: the test tube containing alkane, no reaction occurs and bromine water remains the same in color, that means orange or brown. The test tube containing alkene, the double bond in the alkene reacts with bromine water in an addition reaction. Decolorization of bromine water, that means turns colorless. Reaction with an alkene, example ethene. C2H4 plus Br2 produces C2H4Br2. Dibromoethane is formed and the solution turns colorless. Why does this happen? Alkenes have a double bond between carbon atoms, allowing them to undergo addition reactions with bromine. Alkanes have only single bonds and do not react with bromine water under normal conditions. That's a wrap on our lesson about alkanes and alkenes. We explored their structures, properties, reactions, and even how to differentiate them using Bromine Water Test. Hopefully, this helps you in your GCSE exam preparation. If you found this video helpful, don't forget to like, share, and subscribe to Target Teach Tutors for more chemistry lessons. Comment below if you have any questions, and we will be happy to help. So see you in the next lesson. Bye for now.